Hey, it's Mrs. Mariah here, and going over today's assignment, which is from Lesson 5 in your workbook, page 319. I have you doing numbers 1 through 4 along with number 6. So let's get started. So here at the top, I did write out just a little note from what we did in class today. So we learned about even and odd functions. And the big idea is even functions, opposite inputs have the same outputs. So opposite inputs have the same outputs, whereas in an odd function, today we found that opposite inputs have opposite outputs. Okay? So for number 1, you are determining whether the function is odd, even, or neither. And that's like the rule that you're going to use to figure it out. And so what happens with even in functions is that they end up having symmetry across the y-axis. So you can see how this is like a reflection across the y-axis. And then if we look at, just a couple of points, so this point down here would have the same output as this one over here, okay? This point looks to be at about -3. This one is about +3. And so those would be opposite inputs, but they both are at about -9, so they have the same output. Same thing is true here. These points that are on the x-axis, those have opposite inputs. This would be about -5. This would be about +5. They have the same output of 0. So this first one is even. Okay. The second one, I can tell right away it's not going to be even because I don't see symmetry across the y-axis. And so then I have to think about, could it be odd? Do the opposite inputs have opposite outputs? So here for my input of 2, this point here would be at 2, 8. And so -2, -8 is right here. Okay, so see how my opposite inputs, 2 versus -2, those are opposites of each other, have opposite outputs, 8 versus -8. I can see it again here at this point. This is at 5, -8. And at -5, the function is up at +8. Okay, so again, the opposite inputs, -5 versus 5, have opposite outputs, 8 versus -8. So this would be an example of an odd function. And another thing about odd functions is that they have 180-degree rotational symmetry. So if I turn the book around 180 degrees, which is like a half circle, then you can see maybe it looks like the same function. Okay, whereas this one is like upside down of what it was. All right, so we have even and then odd. The next one down here, so it's kind of like, well, it looks like it could be maybe odd, because I see like, oh, I've got like this point here and this point here, they're like in opposite corners. But if you look closely, the values aren't even that related. So this point right here is where x is -3 and y is -4. But over here, where x is +3, y is 6. So -3 and +3, those are opposite inputs, but -4 and 6, those are not opposite or the same. So it's not even or odd. This is neither. And you just need to have like one point to show that it's neither of those. All right, and then finally, the last one here. I know it's not even because it doesn't have reflection symmetry over the y-axis, but it could be odd. So let's just kind of pick a couple of points. I see this point here. let's see here, maybe 6. So this looks to be about 6, 2, that point that I just highlighted there. And then negative 6, negative 2, negative 6, negative 2. So opposite inputs have opposite outputs. So this is an odd function. Also, odd functions are going to have that relationship the whole way. And so we could see, like I could find other points where that's going to happen. I do notice that both of these that were odd go through 0, 0. And that's another kind of thing about odd functions, is that they go through 0, 0. All right. Okay. Looking at number 2, complete the table for an even function. This is going to be an even function. And so in an even function, opposite inputs have the same output. So here we have input of negative 4, input of 4. They're going to have the same output. So this will also be a 2. Okay, input of negative 3 and positive 3, they're going to have the same output. So this is a 0. Inputs of negative 2 and positive 2 will have the same output. So this would be an 8. And here, inputs of negative 1 and positive 1, again, opposite inputs have the same output. So this is negative 1. All right, looking at number 3. So we have this graph, y equals x minus 2. Is there a vertical translation, so moving it up or down, of the graph that represents an even function? And my answer would be no here. The graph would have to look like this in order for opposite inputs to have the same output. And so a line like that is not going to happen. However, to represent an odd function, that could happen if we were to move this up 2 places. So we just have the line y equals x, has a slope of 1. So anywhere on that line, y equals x, I'm just going to draw it in here. The x and y values are the same. So at this point right here, let's say, this is the point 2, 2. Well, this point over here is at negative 2, negative 2. So opposite inputs have opposite outputs. So for part B, I would say yes. And then what would I do? I would translate the function up 2 places. Okay. All right. Number 4, the function f is odd. So when a function is odd, opposite inputs have opposite outputs. So select all that are true. So we have opposite inputs, but the same output. A is not true. B, we have opposite inputs and opposite outputs. So that's one I would select. C, reflection over the y-axis takes the graph of f to itself. No, odd functions don't have reflection symmetry. They have 180-degree rotation symmetry. So not C. D, reflecting f across both axes takes the graph of f to itself. So across both axes, that's going to be true. So if we reflect over the x-axis, our y's change to the opposite sign, and then we reflect over the y-axis, our x's change to the opposite sign. So we will have opposite inputs have opposite outputs. And then finally for E, this is actually a property of odd functions, is that it does go through 0, 0. So f of 0 is equal to 0. So that one's true as well. You had one more problem to do, just number 6 on the next page. So for A, we have this graph of function f, and for A, you have to graph g so that g of x is equal to the negative f of x. So that means the outputs are going to be opposite for graph G. So let me get a couple colors. So for A, we're saying g of x is equal to the negative of f of x. I'm going to reflect that over the x-axis. So this point will stay the same. This point will reflect here. It's going to be 1, negative 1, and then 4, negative 2 right there, and then 9, negative 3 right here. So this is what g of x will look like. And then we also have to find h of x. H of x is equal to f of negative x. So this time we're going to reflect over the y-axis because the x values will have the opposite sign. So our first point at 0, 0 will stay there. This point reflects over negative 1, 1. This one reflects over the y-axis, negative 4, 2, and then negative 9, 3. And so this is what h of x looks like. All right, and that is the end of your assignment. I hope you found the video helpful.